introduction of structural engineering. Since this is just the introduction, wala tayong masyadong computation dito. Mga concepts, basic concepts, mga introduction to structural engineering, the history. Yung mic, paki-off yung mic nung iba. Si Bea, paki-off yung mic. Okay. So the overview of our chapter 1, lesson 1 natin is the introduction of structural engineering, the analysis and design process, the structural forms, nature of loads, and the building materials. Actually, sa bago nating CMO, we have the total of 3 topics dito sa chapter 1 natin. Pero yung ibang topics na yon is under sa ibang chapter, so hiniwalay ko na siya and I stick dun sa luma kong lecture. And kung titingnan kasi natin dun sa may curriculum, the previous curriculum, we have, sa previous curriculum, may dalawa tayong structural theory. Yung first na structural theory natin is only focused doon sa determinate structure and then sa ating theory 2 sa mga indeterminate structure. Pero sa case ninyo ngayon, pinagsama na yung dalawang theory in one subject with of the time. Kaya na-compress natin. So for the learning outcome of our chapter 1, number 1, we have to know the history of structural engineering and describe the analysis and design process. Kaninong mic yung naka-on? Melbert, paki-off ng mic, okay. We have to describe the analysis and the design process and identify the various types of structural system. And we should know how to select the appropriate building material, appreciate the importance of the codes and specifications. Na nagsagot na kayo ng pretest. Ano lang naman to, madali lang naman to. Sa pretest, hindi nyo kailangang i-perfect. Hindi nyo kailangang i-perfect yung pretest ninyo. This is not recorded. Actually, yung pretest is just a gauge para malaman natin kung ano na yung prior knowledge natin doon sa. So for our lesson 1, we have the introduction to structural engineering, the analysis process, the structural forms and the nature of loads and the building materials.
I know.
Are we okay? Okay lang kayo?
Okay lang, sir.
Let me know kung meron tayong problem, ha? Or later, you can raise your hands kung meron kayong questions. Pwede ka naman mag-raise ng hands, okay? So, let's proceed with the discussion. As you can see in the picture, in our figure 1, you can see here, structural engineering deals with the making of complex systems like the International Space Station, here seen from the departing space shuttle Atlantis. Lumipad to yung space station na to. Dumaan to ng structural engineering, no? Hindi naman to makakapunta ng outer space na sinelect lang yung mga members, sinelect lang yung mga sizes nung part nung structure na yan. So, yan ay dumaan sa structural analysis. In our figure 2, you can see the Eiffel Tower. This is in Paris. It is a historical achievement in structural engineering. So, sikat na sikat. Pag nakita natin kahit ilang line lang, alam natin na Eiffel Tower siya. In our figure 3, we can see the structural engineers investigating the NASA's Mars-bound spacecraft, the Phoenix Mars Lander. So, itong mga structural engineers, ini-inspect nila kung sumunod ba sa specifications, no? Sa design, itong spacecraft na to bago to siya umalis papuntang Mars. So for the introduction of structural engineering, so the definition, structural engineering is a field of engineering dealing with the analysis and the design of structure that support or resist the loads. Structural engineering is usually considered a specialty within the civil engineering, but it can also be studied in its own right. Dito sa Pilipinas, yung mga nag-aral ng civil engineering, no, sila lang yung pwedeng mag-specialize sa structural engineering kasi it is one of the major area nung civil engineering. Structural engineers are commonly involved in the design of buildings and large non-building structures, but they can also be involved in the design of machinery, medical equipment, vehicles, or any item where structural integrity affects the item's function or safety. Ang pinaka-main goal natin dito is the function and safety. Kailangan pag nag-design tayo, magagamit natin siya. Hindi yung nag-design ka nga, maganda siya, pero hindi naman siya functional. Or safety, of course. Pag gumawa tayo ng structure, ang pinakaunang goal natin doon at bakit tayo nagde-design is the safety nung gagamit ng structure. May kiyaw pa ha. Okay, so structural engineers must ensure their designs satisfy within the design criteria predicated on the safety. Structures may not collapse without due warning, or the serviceability and performance. Wherein, kung, let's take an example. Kung titingnan natin dito, if this is your structure, kunwari, kung structure natin to, and this is your beam, and this is your column, no? Actually, pag nagde-design tayo, we assume, so ito yung cross-section natin, no? So we assume that the steel governs the design. This is your steel reinforcement. That is your steel reinforcement. As you can see, kung ito si steel, no, siya ay inassume mo na mag-fail muna. Pag ito ay nagkaroon, no, ng failure, ito yung concrete natin ay itutulak niya. So that's why you can see here, magkakaroon siya ng cracks. Kaya sinasabi dito na structure must not collapse without due warning. So, ibig sabihin dapat merong warning. As you can see, pag may napansin kang mga cracks dun sa major parts of the structure, so sabihin mo na, oh, may crack to, so baka kailangan nating ipa-investigate, baka nag-fail na yung bakal sa loob nito. No? So, kung ganun, makikita, hindi kasi yung ibig sabihin na kapag halimbawa, no, nandito ka, kung nandyan ka, tapos nakakita ka ng crack. Pagkakita mo ng crack, oy, may crack. Pero sabay babagsak na rin siya agad. Kasabay nung pagkakita mo ng crack ay bumagsak na rin agad. So, walang warning. So, dapat merong warning. Serviceability, dapat nagagamit yung structure after siya ay makonstruct. Performance, sabi dito that the building's way must not cause discomfort to the occupants. Nandito ka sa building na to, eh maya't maya kung imaginein mo na lang na ikaw ay nasa ika 100 na palapag, doon ka nag-o-office, no? Andun ka sa ika 100 na palapag. Tapos syempre malakas yung hangin doon. At nagkakaroon ng sway, no? Nagkakaroon ng sway. Mamaya dito na, no, gumagalaw-galaw. Yung office table mo nandito, mamaya nandito naman siya. So dapat hindi ganoon, no? So dapat hindi magkaroon ng discomfort dun sa occupants ng structure. Structural engineering theory is based upon the physical laws and empirical knowledge of the structural performance of different materials and geometries. So skip na lang natin yung iba ha. Medyo madali naman siyang intindihin. Ito. Accreditation, para maging isang structural engineer ka, so kailangan mong magpa-accredit, no, dito sa Pilipinas. Kailangan nating magpa-accredit kay ASEP, no, magpa-member ka kay ASEP. So we have associate member bago ka maging full member. So in the Philippines, ang ating organization ay tinatawag na ASEP, or it is also known as the Structural Engineers Association of Structural Engineers of the Philippines. Okay, so let's proceed with the history of structural engineering. In this figure, you can see this is the Pont du Gard in France. Now, this is the Roman era aqueduct circa 19 BC. When we say aqueduct, the word aqua means water, and duct means to convey. to convey water, no? Aqueduct. So, ibig sabihin nito sa panahon ngayon, ito na yan siya yung mga tubo, no? Yung mga tubo papuntang bahay sa water system. Sa panahon nila, this is the aqueduct. Pero sa modern age natin ngayon, ito na yung katumbas niya yung mga tubo, no? No, yung sa may water system. Structural engineering dates back in 2700 BC, where the step pyramid of Pharaoh Djoser was built by Imhotep. So Imhotep is the first engineer, no, in history known by name. Pyramid were the most common major structure built by the ancient civilization because of the structural forms of the pyramid is inherently stable and can almost infinitely scale as opposed to most of the other structural forms which cannot be linearly increased in size in proportion to the increased loads. No, so actually siya rin yung naging ano no? Parang naging basis tong mga lumang ano natin, lumang structure natin dito sa Pilipinas. Yung mga simbahan, ang lumang simbahan, kung mapapansin niyo, yung kanilang wall. Ganito yung pagkakalatag ng wall. Mas malapad, no, yung area, no, cross section doon sa lower part tapos paliit ng paliit papunta sa taas. May class ako din. Okay, so for the timeline, ito yung mga yung mga pangalan na dapat nating tandaan. In 1452 to 1519, si Leonardo da Vinci made many contributions. Sino nakakakilala kay Leonardo da Vinci? Anyone? Leonardo da Vinci? Hindi ka na-inform na may recitation. Sino nakakilala kay Leonardo da Vinci?
Famous painter, sir.
Yes, no. Yung pagkakilala natin kay Leonardo da Vinci ay pintor, no? Pero si Leonardo da Vinci ay isang engineer. At marami siyang contribution sa structural engineering. In 1638, si Galileo Galilei, pag narinig mo yung pangalan ni Galileo Galilei, yung una mong maiisip is yung telescope, yung moon, Galileo Galilei. Published the book to New Sciences in which he examined the failure of simple structures. In 1660, si Hooke's law naman was developed by Robert Hooke. Napag-usapan na natin to sa ating deformable, si Hooke's, the Hooke's law, Robert Hooke. Isaac Newton naman published the Philosophiae Naturalis Principia Mathematica, which contains the Newton's law of motion. So, alam na rin natin yung tatlong law of motion by Newton. In 1750, si Euler-Bernoulli beam equation was developed. Guys, we have to remember that this is pronounced as Euler, not Euler, ha? Euler yan siya. Kasi French yan siya. In 1700 to 1782, Daniel Bernoulli introduced the principle of virtual work. Si Leonard Euler naman developed the theory of buckling of columns. When we say buckling of columns, kung ito, no? Kung ito yung column, assume nyo na lang na straight yan. When we say buckling, no? Nagganon siya, no, na tumutupi, no? Or the buckling could be like this. No? Si Euler yon. So Euler ang nag-develop ng buckling of columns, yung theory nun. And in 1826, si Claude Louis Navier naman published the treatise on the elastic behavior of the structure. In 1873, si Carlo Alberto Castellano presented his dissertation in torno ai systemi elastici, which contains his theorem for computing the displacement as partial derivative of the strain energy. Masasalubong natin si Castellano theorem sa ating chapter 8. In 1936, Hardy-Cross publication in the moment distribution method. Sa moment distribution method, masasalubong natin siya sa chapter 10. Si Alexander Henry Koff naman submitted his Doctor of Science thesis in MIT for this criticization of the plane elasticity problem using the lattice framework. And si Arcourant naman divided the domain into finite subregions, so that way now we have the finite analysis. And itong tatlong to, yung apat na to, so no, the stiffness and deflection of a complex structure introduces the name finite element method. Si finite element method is one of the course offered no, sa masters na to siya. Okay, in figure 5, you can see the Sydney Opera House. This is designed by Ove Arup and partners with architect Jorn Ortson. In figure 6 naman, you can see here a structure, the Millennium Dome in London, UK, by Burrow Happold and the Richard Rogers. Sa figure 7, this is the Burj Khalifa in Dubai, and this is known as the world's tallest building. So, hindi ka magkasya sa, sa screen. Char lang. Structural building engineering includes all the structural engineering related to the design of buildings. It is a branch of structural engineering that is close to architecture. Skip na lang natin yung iba. Okay, so let's proceed with the systematic and iterative process of structural design. Ito lang tatandaan natin, ano yung process, sino yung involved. In our step number 1, so the identification of the intended use and occupancy of the structure by the owner. Of course, yung owner, yung magde-decide kung ano yung structure, no? Kung ano yung building na ipapatayo niya. Hindi yung ikaw, no? Parang kunwari, sasabihin mo na, uy, may pera ka naman, patayo ka naman ng ng condo. Magpatayo ka naman ng ng mall. Baka gusto mo magpatayo ng bahay, no? Hindi ikaw yung nagde-dictate. Si owner yung nag-identify ng use and occupancy ng structure. So, kapag nakaisip si owner na magpagawa ng isang structure, of course, yung pinaka talaga dito is lalapit siya, of course, kay architect. Si architect will develop an architectural plans and layout. After that, ipapasa ni architect to kay engineer, identification of structural framework, and the estimation of structural loads depending on the use of occupancy. Of course, si engineer pa rin to. Number 5, the analysis of the structure to determine the member and connection design forces. So, after the magko-compute na to si engineer, ano yung pinakamaliit na size ng column, ano yung pinakamaliit na size ng beam, no? Si engineer pa rin to. And the design of structural members and connection, no? So, this is kay structural engineer pa din. Of course, and then the verification of the design. Sa kanya pa rin or pwedeng magkaroon ng third party to verify the design. And number 8 is the fabrication and erection. So, kung steel man to, so this is, syempre may steel fabricator and si contractor naman ang involved dito. And after na matapos na yung structure, there is an inspection and approval by the state building official. Etong mga to, actually, kasi since ang sinasabi kasi dito, systematic and iterative. When we say systematic, sunod-sunod to. Hindi ka pwedeng lumaktaw na galing dito kay owner, naka magbe-verify ka na agad ng design, wala pang ang drawing, no? So dapat sunod-sunod kasi siya, systematic. Iterative naman in such a way na halimbawa, pagdating natin dito sa analysis of the structure, may nakita si engineer na ay hindi talaga to po pwede dito sa part na to. So baka pwedeng pakibago yung mukha nitong part na to. So kung may mababago sa mukha ni no, so kung mababago yung may mababago sa mukha ng layout, babalik ka sa step 2, no? Wherein magkakaroon ng revision si architect. Tapos babalik ulit hanggang sa baba. That's why it's called iterative, no? Systematic and iterative process. Okay. So ano yung mga role dito? Si owner, the primary responsibility is deciding the use and occupancy and approving the architectural plans of the building. Si architect naman is primarily responsible in ensuring that the architectural plan of the building interior is appropriate for the intended use in the overall building is aesthetically pleasing. Yun kasi yung pinaka goal kung bakit may architect. Dapat maganda yung mukha, no? Yung tipong pagkakita mo ng structure, yung laglag pa nga, tulo laway, ganun. Si engineer naman, the responsibility is ensuring the safety and serviceability of the structure. It is designing the building to carry the load safely. Si fabricator is primarily responsible in ensuring that the design members and connections are fabricated economically in the shop or field as required. Constructor or erector primary responsibility is ensuring that the members and connections are economically assembled in the field to build the structure. Si state building official naman, primary responsible in ensuring that the built structure satisfies the appropriate building codes accepted by the government. Now, let's proceed with the classification of the structures. May dalawa tayong classification. One is the under the structural element, and the other one is the types of structure. Now, isa-isahin natin. For the structural element, the first one is the tie rod. Structural members subjected to tensile force are often referred to as the tie rods or bracing struts. Due to the nature of this load, this member are rather slender and often chosen as rod, bar, angle, or channels. No? Makikita natin dito, itong mga to, no? They are referred to as tie rods. Dito, no? So ito siya, oh, yung part na to, yung cross bracing na to, yung galing dyan, connecting, papunta doon, cross bracing, and this one papunta doon, usually round bar yan siya. Those are tie rods. Beams are usually straight horizontal members used primarily to carry vertical loads. So quite often they are classified according to the way they are supported as indicated in the figure 9. Ito yung common. No? So the simply supported beam wherein the other end of the beam is a hinge and the other is a roller. We have the fixed supported beam or minsan ay referred to as fully restrained. Yung magkabilang dulo niya naman is fixed. And the cantilever beam, yung fixed support on the other side and hanging naman siya on the other end. Continuous beam, so series of hinge and roller. Dire-diretso lang to siya. Kung titingnan natin, usually kasi yung take tayo ng example ha. Kung gusto mo tumawid sa tulay, actually nakwenta ko na to dun sa ano natin, sa may shared moment diagram. Kung gusto mo tumawid sa tulay na ganyan kanipis, maliit lang, manipis lang. Ito ka. Yan. Or tatawid ka sa tulay na mas makapal. So, yung tendency na ang tulay na to ay mag-bend, no? Kapag ikaw ay tumawid, given that you are a concentrated load, no? Kaysa naman sa ganito kakapal, hindi ko alam kung ilan kayo para mapabend to. Kaya ang ginagawa ng iba, para maging economical yung design, sa halip na rectangular yung gamitin. Kasi sabi nga, mas okay kung ito si height is higher or greater kumpara dito sa width natin. No? So kaya yung iba, since height naman yung i-consider natin, binabawasan yung cross section. And in this case, nagkakaroon tayo ng mga wide flange, no? Wherein ito yung part na to is referred to as the flange. The flange. At ito, ang part na to is referred to as the web. Ito yun siya. Sometimes, kung masyadong malaki, no? Masyadong malaki yung gagawin, walang available sa market. So, nagpapabricate lang sila. So, dito naman papasok ngayon yung mga plate girders na tinatawag. And in this case, this is a press-stress concrete girder, simply supported naman to siya, that are used for the highway bridge. Next one is the column. So, kilala natin si column. Pag sinabing column, poste, haligi. No? Members that are generally vertical and resist axial compressive loads are referred to as columns. So, tubes and wide flange cross-sections are often used for metal columns and circular and square cross-sections with reinforcing rods are used for those made of concrete. So, kapag concrete yung column natin, meron tayong steel reinforcement. So these members are referred to as, sabi niya, if the column is subjected to both the actual load and the bending moment, referred to as the beam columns. Ano pinagkaiba nun? Pag pure axial yung loading natin, ito at ito, pure axial, then that is a column. But if we have a moment and an axial load, that is referred to as a beam column. So in this figure, we can see a wide flange member, no, which is often used as column. So this is an example of a beam column. So types of structures, we have first the truss. Alam na natin si truss, kilala natin si truss. In this course, mapag-aaralan natin yung iba't ibang uri ng trusses. The first one is the simple truss. So, ito lang siya, kunwari. Simple truss. Next time ko na-straighten yung drawing ko. Yan. Ang pangit, diba? Ulitin natin. So, this is tabing pa din. Yan. Kunwari, that is the simple truss. The simple truss. When we say compound truss, this is a combination of simple trusses. Pinagsamang simple truss. Magiging compound. Kunwari ito. And they are joined by one point here, one joint, and one member. Actually, meron tayong tatlo, no? Meron tayong tatlong paraan paano mag-join ng simple trusses. And one joint and one member. One simple truss plus one simple truss, and we created a compound truss. The next one is the complex truss. Si complex truss, ito na yung ganito yung mga itsura, yung nagko-cross-cross na, yan, or mukhang star, no? Yan. This is a complex, simple, compound, and this is complex. Itong tatlong trusses na to, they are referred to as coplanar trusses. Bakit siya sinasabing coplanar? Kasi kung this is the framing, ito yung framing natin. Kung yan yung framing natin, no? Ito, nasa top view tayo nito ha, nasa roof plan tayo. Ito yung line na to, this line here is your truss. No? Na kung titingnan natin, dito tayo titingin, ito yung makikita natin. So, this is coplanar. Ibig sabihin, kung titingin ka sa side na to, kung makikita mo lang, ay ito. The other one, the fourth type of truss is the 3D truss, space truss. Si space truss, ito na yung mga ganito na yung mukha. No? Three-dimensional na yung treatment natin sa kanya. No? First, that is the load. This is a 3D truss. So, halimbawa, may support tayo dyan. We have a support here. And we have another support here. Space truss. So, I think okay na tayo kay trusses. In figure 16, we can see the loading causes bending of the truss, which develops compression in the top members and tension in the bottom members. So, dumaan na rin tayo sa analysis of truss last time. Simple lang, kahit sa simple analysis lang. The joint method and the section method. So, makaka-relate ka na doon sa which part of the truss is in compression and which member is in tension. The next one is the cables and arches. No? So, cables. Ipunta na lang tayo dito. Magkabaliktad to sila kasi si cables, kung makikita natin, if this is a bridge, no, a suspension bridge, you have the tower here and you have another tower here. This is the supporting cable. Kung ito, no, itong mga to, these are the cables. No? If we are going to cut this, makikita natin dito, ito yung action pag kinat natin yan. So meaning, if we take this lower part, ang makikita natin doon ay ito. So itong mga cables na to, they are subjected to a tensile load. While in this one, arc naman yung ginamit niya since this is an arc, no? Arc yung gamit. This is the arc. And it is subjected naman sa compression kasi ito yung mangyayari. Magsasalubungan sila. This is subjected to compressive loading. That is an arc. Okay, so let's proceed with the frames. See, frames naman are often used in buildings that are composed of beams and columns that are either pin or fixed connected. Pag sinabing frame, this is a combination of a column and no. So this is a column, or so that is a column fixed. This is a beam and a column. Yan. And this is referred to as a rectangular frame. If we have here another frame, yan, another frame, and this is a hinge. No, this one is a gable frame. So sinasabi dito na this part here can be connected by bolted or welded. Pag bolted, so this is assumed as pin connection. Pag welded, this would be assumed as fixed connected. Surface structure is made from the material having a very small thickness compared to the other dimension. Masyado siyang manipis. That's why surface structure, no? Sabi niya dito, surface structure may also be made of the rigid materials such as reinforced concrete. As such, they may be shaped as folded plates, cylinders, or hyperbolic paraboloids, and are referred to as thin plates or shells. So in this case, ito siya. Yung yung roofing ng Georgia Dome is considered a thin membrane. Masyado siyang manipis kumpara dun sa buong part ng structure, no? And it is referred to as a surface structure, a thin plate or a shell. Now let's proceed with the structural loads. Umpisahan natin sa dead load. Dead load are permanent load acting on the structure. This include the self-weighted, the structural and non-structural components that are usually gravity loads. Kung ito yung structure mo, ito yung structure mo. Halimbawa, ito yung i-drawing ako na hiwalay. Gawin ko na tong truss. Ito yung beam natin. May sarili siyang bigat. No? Sarili niyang bigat, and this would be referred to as the dead load. Yung self-on weight, no, ng structure natin. The permanent loads, yung nandyan na sa structure, nakakabit sa structure na hindi natin naaalis, those are considered as dead load. So, ulitin ko, this include the self-weight of the structure. When we say live load, they are non-permanent loads acting on the structure due to its use and occupancy. The magnitude and location of the live load changes frequently over the design life. Hence, they cannot be estimated with the same accuracy as the dead load. Sa dead load kasi, kapag ganito yung material, so alam natin gaano to kabigat, ano yung unit weight ng material na to. Pero sa live load, hindi. So, titingin lang tayo sa figure, ano yung gamit nito nung part na to. And doon natin makukuha yung value ng live load natin. So, ano-ano yung mga live load? Ikaw, kasama ka sa live load. Kasi kung imagine mo yung sarili mo, dito ka, andyan ka. Hindi po pwede na nandyan ka lang all throughout your life. Hindi ka pwedeng umalis kasi you consider yourself as a dead load. Live load ka, so ibig sabihin, wait lang.
Boy.
Since live load ka, pa-mute po ng iba.
Ha?
Since live load
Hindi ko alam,
ka,
boy.
pwedeng nandito ka, or bukas nandito, o mamaya-maya nandito ka na naman, palipat-lipat ka, so live load ka. Yung office table mo, andyan siya, pwedeng nandito siya bukas, nandyan siya bukas, live load siya. So, hindi siya permanent load. Wind load are in the form of pressure or suction. When we say pressure or suction, kasi
Mabilis yung kamay mo.
halimbawa, this is your structure. This is your structure. Ito yung part na to kung saan umiihip yung hangin ay tinatawag nating windward side. And this part here sa kabila, tinatawag nating leeward side. So, in the windward side, yung structure is experiencing pressure. Ibig sabihin, this is directed towards the structure. While in the leeward side, this is experiencing suction. The loading is away from the structure. So, we always remember that this side, kung saan nagbo-blow yung hangin, is the windward side, while this other side is referred to as the leeward side. So, later may papanood ako dito sa wind load. Next one is the snow load. No, sa snow load or vertical gravity load due to snow. Wala naman tayong snow dito sa Pilipinas, pero kung syempre ano lang naman to. Kung self-explanatory. Snow load, ibig sabihin is snow. Roof live load or live load on the roof caused during the design life by planters, people, or by worker, equipment, and materials during the maintenance. No? So yung mga non-permanent load natin doon sa ating roof is referred to as the roof live load. Values of structural loads are given in the National Structural Code of the Philippines or yung tinatawag nating NSCP version 2015. The first phase of structural design consists of estimating the loads acting on the structure. Ito yung occupancy category galing sa section 103 of the NSCP 2015. So for the category 1, ito yung mga tinatawag nating essential facilities. Ano-ano yung mga kasama sa essential facilities? Mga hospitals with occupancy having surgery or emergency treatment areas are under the category 1. Yung mga fire and police stations, category 1 yan siya. Garages and shelters for emergency preparedness centers, aviation control towers, the structures and shipment and communication centers and other facilities required for emergency response, the facilities for standby power generating equipment for category 1 structure. Yung tanks or other structures containing housing or supporting water and other fire suppression material or equipment required for the protection of category 1, 2, or 3. This is 3, 4, and 5 structures ay kasama sa category 1. Public school building is category 1. Hospitals, category 1. Designated evacuation center, category 1 din yan. And the power and communication transmission lines is considered as category 1. Yung mga category 2 naman, the hazardous facilities, ito yung mga occupancy and structures housing or supporting toxic and explosive chemicals or substances, yung mga delikado. Non-building structures storing, supporting, or containing quantities of toxic or explosive substances, those are under the category 2 structures, hazardous facilities. Number 3, or category 3, is the special occupancy structure. These are the building with an assembly room of an occupancy capacity of 1,000 or more. So kapag yung isang building ay naka-design for 1,000 occupants or more, then those are considered na under siya sa category 3. Education buildings such as museums, libraries, auditorium with capacity of 300 or more occupants, then category 3 siya. Building used for college or adult education with capacity of 500 or more occupants, then those are under the category 3. The institutional buildings with 50 or more incapacitated patients, yung but not included in category 1. Bakit hindi siya included sa category 1? Sa category 1, those are the health structures na kasi nakalagay doon, 'di ba? Doing the surgery. So yung hindi nag gumagawa ng surgery, it would be under the category 3. Mental hospitals, the sanitariums, the jails, prisons, and other buildings where personal liberties of inmates are similarly restrained are under the category 3. Yung mga churches, mga mosques, and other religious facilities, all structures with occupancy of 5,000 or more, structures and equipment in power generating stations and other public utility facilities that included in category 1 and 2 would be considered as category 3. Ito yung pinakamadaling tandaan. The category 4, standard occupancy structure. Lahat ng hindi na list sa 1, sa 2, sa 3, at sa 5, automatic sa 4 siya. Madaling tandaan. Pero kailangan mo mag-elimination muna. 5 is the miscellaneous structures. These are the private garages, the carports, sheds, and fences over 1.5 meter high. So, source natin dito is the NSCP 2015. Yung dead load natin, so as I said, the dead load consists of the weights of all materials of construction incorporated into the building, including but not limited to walls, floors, the roof, ceilings, stairways, built-in partitions, finishes, the cladding, and other similarly incorporated architectural and structural items and fixed service equipment such as plumbing, stacks, and risers, electrical feeders, and heating, ventilating, and air conditioning systems. Makikita natin dito sa table na 'to. These are the list, 'no, ng mga minimum design load, dead loads natin, 'no. So dito tayo titingin kung gagamit tayo ng wait, ayan. So kung plywood, so this would be the value. And our value is in kilopascal. Kilopascal to. So kapag bricks, no, pag bricks 100 mm, ito siya. Pag 200 mm, ito siya. So technically, titingin tayo dito, no, sa table na to kapag nag-design tayo. So cement finish, we have 1.53. Stone concrete, this is 0.023. The cinder concrete, we have 0.017. So lightweight concrete, that is 0.015. Sand is 0.015. Technically, titingin lang tayo dito. At ito is lifted from NSCP 2015. Doon ko to siya kinuha. Ito naman yung listahan natin ng live loads natin. This is uniform and this is concentrated. So, titingnan natin, okay, kung residential, ano ba to? Ang purpose na to? Ano yung occupancy natin? Is this office? Is this residential? Restroom ba to? No? So, residential. Okay, residential. Decks, meaning this is yung mga roof decks. No? So, we will be using the uniform load of 1.9. No? Okay, so doon lang. Titingin lang tayo sa table. And special loads. So, special loads is under din yan dito, no? Sa ating dead load. Roof live load naman. So, ito lang titingnan nating value. And you have the tributary area. Ano yung sinasabi ng tributary area? Ito lang po yung tributary area. No? Kung ito yung part na to, this is the part of the roofing. Yan. Kung ito, kung i-shade natin ha, kung i-shade natin to, yan, kung i-shade natin to, itong part na to ay kakargahin, itong kalahati, kakargahin nun. Ang kalahati nito, kakargahin nito. So, ang kalahati nun, kakargahin nun. Yun yung tributary area, no? Paghahati-hati, kaya sabi, itong kalahati mapupunta sa kanya. Itong kalahati mapupunta sa kanya. Yung kalahati nun mapunta sa kanya. Kaya ang tawag doon, hating kapatid, lamang ang dalok. Ayan. Wind load. So wind load, the design wind load for building can be based on the simplified procedures given or the analytical procedure, wind tunnel or small scale procedure. Pag mapanood natin, no, yung video na nandun sa activity, meron silang wind tunnel doon na pinakita. Lipat muna tayo dito. May papakita lang akong video. So this is a Tacoma Bridge.
As you can see, this bridge was exceptionally long and narrow, over half a mile long, only 39 feet wide. It lasted just 4 months. Eight feet tall, which were supposed to
Ayun siya. So, start the resonance vibration will reach a torsional mode. That is in November 1940.
On November
Ayan. Kung
7th,
makikita
the
nyo
bridge
doon,
suddenly went into a
gumagalaw yung
twisting
waves.
motion.
Ayan.
The wind speed
Nag-warp
was a
siya.
steady
Concrete
42
yan.
miles per hour.
Concrete
This was
yan
enough
siya.
to keep the bridge oscillating in one of its natural modes of vibration with a period of 5 seconds. A professor of engineering went out to see what had happened. He's coming back, walking with some difficulty along the nodal line, which is the center stripe of the roadway.
I-forward ko na naman. Ayan. So, makikita nyo kahit concrete
It's
siya, ganun siya
remarkable that the
ka-flexible.
girders were this flexible. This is photographed at normal speed. However, a collapse was inevitable after a little more than an hour of this.
May tao pang tumatakbo.
The car had been abandoned earlier. No one was injured in the whole affair. However, a small dog in the car was frightened and was afraid to come out, and he perished.
Ayan. So, bumagsak na siya. And ang pinaka main cause niyan is failure, no, dito sa wind load. So other loads designed for earthquake load o yung tinatawag nating seismic load, no, can be seen in the section 208 of the NSCP. The other load are pressure, fluid pressures, the lateral soil pressure, pumping loads, and self-straining forces, which can be seen also in NSCP section 206.2. And we'll proceed to our last topic, the building material. So meron tayong 5. The first one is the wood. Wood, we have 3 types, the balloon framing, platform framing, and the heavy timber framing. You can Google naman kung anong mga mukha na itong mga to. Advantages, the only renewable material is the wood. Siyempre, tumutubo siya eh. Warm and natural appearance, low energy required, hindi mo kailangan ng malaking equipment, no? Kapag mag-construct ka using the wood as your material. Easy to work and siyempre medyo mura. Pero sa panahon ngayon, hindi na siya mura. Dati pa yun. Challenges, combustible, madali siyang masunog, syempre. Termite attack, pwedeng anayin. Decays in variable humidity. So, pag na-expose yan sa ulan-init, madali siyang magrupok. Limited height and floor area. Hindi ka naman pwede mag-order ng isang street na 5 palapag na isang buong kahoy, di ba? Ayan. So, second is the steel. So, types, we have W shape, yung tinatawag nating yung wide flange, no, yung mga W shape. The S, hindi siya mukhang S, this one. Ito yung mukha niya. Standard, no, S shape. And we have here a wide flange, the number 4. Ito to, tingnan na natin yung figure. And the C, yung C shape, yung tinatawag nating channel, usually tinatawag natin to common sa common term na is tinatawag nating C purlins, no? Ayun yun siya, yung mga C channel na yan, yung mga channel. Kung titingnan natin, saan kayo makakita nito? Imagine niyo na dito kasi WPU. Tapos naglalakad kayo galing ng main gate. Tapos nandun na kayo sa covered walk. Makikita nyo to, itong part na to. Ito yung mga C, no? Yung C purlins na yan. Yung pinagpapakuan siya, no? Ng roofing. Those are the channel. We have the angle. Ito yung kilala nating angle bar. Meron tayong equal leg niyan, merong unequal. Pag sinabing double angle, ito yung naka back to back lang. You have the angle here and another angle here. Yan, double angle. And we have the pipe tubo. So standard, we have the extra strong, we have the double extra strong. Pag tubing, ito yun, no, yung tubular. We have the square, yung tinatawag square bar, and the rectangular. Yung advantages nito, it is high strength, of course. High strength means the load carrying capacity. Uniformity, properties do not change appreciably over time. So kung ang shape niya is a channel, hanggang sa ilang panahon, channel pa rin siya. Uniformity. Elasticity, so it follows the Hooke's law after the fairly high stresses. Permanence will last indefinitely, of course. Ductility, ability to deform significantly without failure. Toughness, it is the strength and ductility. Geometric flexibility, so addition to existing structure. Kung meron ka ng existing structure dito, yan, tapos magkakaroon ka ng extension, mas magandang gamitin yung steel. Miscellaneous, so it can be fastened together by simple connection, adaptation to prefabrication, speed of construction, can be ruled in various sizes and shapes. Ang disadvantages lang nito is the maintenance cost, of course, the fireproofing cost, susceptibility to buckling, fatigue, and brittle failure. Concrete. So concrete, we have the three types. We have the side cast, the precast, and the press-dressed. Ano pinagkaiba to ng mga to? Pag sinabing side cast, so halimbawa ito yung flooring natin. Flooring na lang, mas madaling tingnan. Kung yan yung flooring natin, this is referred to slab on grade, or SOG, or SOF, slab on fill. Yan. Pag dito binuhos yung concrete, at dyan na siya tumigas, ang tawag sa kanya, side cast. Pero kapag yung concrete ay yung pinakamagandang tingnan, pinaka-common nakikita natin yung concrete posts, yung ginagamit sa fencing. Sa ibang lugar siya hinulma, pero dadalhin mo siya doon sa paggagamitan niya ay ibang lugar. Ibig sabihin dati na siyang tumigas, dinala mo siya doon and gagamitin sa construction. Ang tawag nun is precast. Pag sinabing press-dressed, kung napapansin niyo yung mga gumagawa ng tulay, kung may yun dyan, yung sa may Malatgaw, no? So if this is the beam, naglalagay sila ng tendons. Doon may tendons. May tendons, usually nakaganito. Tapos babatakin nila to. Babatakin nila yan. That is pre-stressed. Ina-apply natin yung stress dito sa structure bago pa man siya gamitin, no? So usually yung mga pre-stressed ay hindi siya prone sa cracking. Advantages, widely available of course yung concrete. Can be recycled. Kapag nag-demolish ka, pwede mong gamitin ulit as aggregates. Can be many finishes. Kung ano yung itsura ng hulmahan, yun yung maging itsura niya. Pero kung kahoy, kailangan mo pa siyang ukitin. Takes any form, of course, fire resistant and durable. Yung challenges nito, heavyweight siya. Requires reverse to resist tension, so possible cracks without pre-stress. Sabi ko nga kanina, kapag yung mga pre-stress, hindi siya prone sa cracking. Kung makikita natin, if this is our beam, at balikan natin yung topic natin dun sa shear and moment diagram. Dito sa midspan natin, So imagine natin na ito ay magbe-bend na siya. So that would be, ito na yung mukha niya nung nag-bend na siya. On the upper part, this is in compression, and the lower part is tension. Baliktad naman to sa support. The other part, sa taas ng neutral axis is tension, and below the neutral axis is compression. And the same here, tension, compression. So sinasabi niya dito that the tension side requires rebars to resist tension kasi yung concrete is matibay siya sa compression pero weak siya sa tension. So that's why dito sa part na to, kailangan mo ng bakal. Kailangan mo ng bakal, of course, to resist tension. Kaya napapansin ninyo sa mga kalsada, kung ito yung roadway, wala kang nakitang parilya dun sa kalsada. Hindi mo to nakikita. Kasi kung titingnan natin, itong kalsada is pure compression. So, strong na siya sa compression. Hindi niya kailangan ng bakal. Yung nakikita nating bakal dito, nilalagay lang yan siya as construction joints. Pati doon, pag nagputol ng buhos, you have the construction joints. So properties, strong in compression, weak in tension, steel rebars resist tension, of course. Masonry. So we have 3 types. We have the brick, the concrete, and the stone. So alam naman natin yung brick, and we have the concrete, no? At yung bato, no? Yung mga bato na pinagpatong-patong, masonry. Usually riprap, mariprap siya. Advantages, widely available siya, can be recycled, of course, earthly appearance, fire-rated, and durable. Yung challenges nito, heavyweight siya. Lalo na kapag nag-fail, kapag may lindol. Requires rebars to resist seismic forces, so kailangang maglagay pa rin ng rebars. And limited yung height kasi pag sobrang taas na, pwedeng syempre mag-fail to siya. Hindi naman kasi siya dugtong-dugtong, grout lang yung nagdudugtong sa kanila. So this is a Roman aqueduct in Segovia, Spain, and this one is the Roman aqueduct, the Portugard in France. They are made of masonry. And the last one is fabric. So fabric, we have the anti-plastic, the air supported and air inflated. So advantages nito, lightweight siya, translucent. Of course, sa umaga o sa araw, it saves the energy. Yung challenges nito is the fire rating, no? So kasi madali siyang masunog eh. And the durability is about 20 years. This is the San Diego Convention Center, the anti-plastic roof, no, yung ginamit. Ito yung mukha niya. Pag mapanood nyo yung video, dito sa activity ninyo, this one, the Burj Al Arab, i-brief ko lang kayo. Ang titingnan natin dito is the design process. Titingnan natin kung ang design process ba, iterative process, design, the systematic and iterative process ay nasunod. So simula doon kay owner, pupunta kay architect, pupunta kay engineer, sa nag-design ng engineer hanggang sa dulo, yung building ipag-accept na ng project. And of course, ano yung mga loads no, na nandito, na kinonsider nila. And ano yung mga building materials na ginamit. No? So halos lahat nandito eh. May steel siya, may concrete, meron din siyang, this part here, ito yung puti na to sa harap, fabric to siya. No? So write your answer in A4 size bond paper and it's handwritten. Kailangan nyo siyang isulat kamay. Later, isi-share ko rin to, yung link na to dun sa group. Pero kailangan kong i-approve para mapanood nyo siya. And the same, of course, dito sa gagawin nyo rin, dito kay Agas-Agas Bridge. So far, wala pa tayong deadline nito. Mag-a-announce na lang ako. For evaluation post-test, madaling sagutan. Huwag mangopya sa loob. Be honest. No? So, madali lang ito. Kayang-kaya. References, kung gusto nyo pang magbasa. No? So, ito yung gagamitin natin. Ayan. Okay, so that's it for our chapter 1. May tanong ba? Pwede na kayo mag-on ng cam and mic. Okay lang tayo.
Sir, nagabagyo na dito.
Hindi pa ganun ka stressful yung chapter 1 kasi puro kwento pa lang. Wala pa tayong computation diyan. Kawawa naman ito sa Kapukaw ngayon pala mag-join. May tanong ba?
Sir, kailan daw po yung deadline dun sa reflection?
Wala pa tayong deadline. Take your time.
Kahit ilang words lang, sir.
Basta nandyan yung kumpleto. Kailangan makita ko yung iterative process. Kailangan makita ko yung building material. Kailangan makita ko kung sino yung mga key players. Kailangan makita ko kung lahat ng part ng chapter 1. I-relate nyo siya sa topic ng chapter 1. Yung loading, structural loads.
Sige po, sir.
May tanong pa?
Okay na ako, sir.
Wala na bang tanong?
Ay guys, magtanong na kayo kasi mamaya sa GC magtanong-tanong na naman kayo.
Baka may itatanong kayo para masagot ko na siya agad.
Wala. Ayan yan, sir.
Okay na siguro kung wala na rin. So that's it.
May tanong, sir.
Sige, go. Rico? Si Rico ba yun?
Sir, nagtatanong si Rida kung may na-record po kayo.
Oo, nagre-record ako. Nagre-record ako tapos i-upload ko to siguro sa private na YouTube lang siguro na yung may link lang yung makakakita, hindi siya nasa-search.
Sir, sayang ang kita.
Huwag muna. Tsaka na. Wait lang. Mamix. Po. Ay, forward ko lang sa'yo, Mamix. Teka lang po. May tanong pa ba?
Sir, may na-record daw po kayo sa tinuro nyo ngayon?
Nagre-record po ako.
Kasi po mahina po yung connection namin dito, kaya putol-putol.
Sige, i-share ko na lang pag na-upload ko na.
Sige po, thank you po. Yung pasahan po ng
Wala pang deadline. Siguro kapag nagbigay na ako ng kasunod na na module bago na ako mag-start mag-collect ng inyong output.
Ano yun, sir? Buo po siya? Kapag once na nag-deadline na po siya, buo po siyang ipapasa sa inyo?
Dalawa lang, lang naman, yung lang muna. Pero pwede na kayo pagkatapos yung masagutan yung yung post-test, pwede na kayo mag-submit. Yung pre-test hindi nyo i-submit.
Sige po, sir.
Post-test lang at saka yung activity.
Sir,
Yes po.
saan ko ipapasa sir yung yung post-test po at saka yung activity?
I-post ko lang yung email or pwede siyang i-PM. Pero ang sabi ko sa activity, handwritten siya, tapos pipicturean nyo na lang siya as PDF. And then, isisend nyo sa akin, PDF file.
Sige sir, salamat po.
Okay na. Screenshot muna tayo ng first meeting natin. Screenshot. Paon lahat ng cam. Paon lahat ng cam.
Share na lang. Woohoo!
Paon na. Dali na. Mag-screenshot na.
Oo, Kuya Rico.
Wala share.
Tapos sabi niya, paano
Okay na, sir.
ba? Paano ba yun? Screen lang. Si ano pa? Attendance to. Dito na nga lang. 1, 2, 3, smile. Next. Ay, may naka-uniform pa, oh. Feel na feel yung pasukan.
Kawawa naman si Charis, sir. Oh.
1, 2, 3, smile. Bakit?
Galakad-lakad. Naglalakad-lakad, naghanap ng signal.
Oh, ganun. Oh, sige na. Okay na to.
Hoy, Bri, hindi kaya.
Bye-bye na.
Bye-bye, sir.
Bye, sir. Salamat po.
Enjoy yung first module nyo.
Sige po.
Bye.
Thank you, sir. Bye-bye.
Bye, sir.